Hello, and we are live. This is the episode 6 of building an emulator with Rust. Uh, and today we're gonna do more opcodes and fix something. But before, I need to do two things. First, uh, I did some refactoring. Actually, not yeah, I did one fix off screen and put some debug messages in the code, and I just saw that Saturno Zmart get back to my channel again and left another very good comment, and I would like to go through it in the beginning of the video. Then I will tell what I did already. So before going to the comment, I actually uh, will tell what I did off screen uh, uh, this morning. So I had some time this morning. I decided to do some fixes because okay. So let's go through it. Yesterday we went through. Oh, this is a new opcode table which I get from the guys from uh, GBDev Discord. Those guys are amazing. And they helped me to fix the bug. Let me go through the fix. I mean, there was a bug in our code yesterday, and let me show you how I realized that was a bug. So I left it yesterday. We left at the point that we are using the boot room, and this is a disassembled version of the boot room, which is the binary file is this. Okay, so we are loading it and we are coding the instructions as it appear in the while we are reading the ROM. So I realized that this first part of the instructions, as I have it here from the Mike Steele, I think this is the name. Uh, this part of the instruction is set to here, so to the uh, 207 is for init run. Okay, so we are starting doing setup of audio according with this page. And here's something in this comment that get my attention. It says that we are putting zeros in the memory from this address to this address, which is the video RAM. Okay, so I saw this is the video this so this is the video RAM. Okay, so here from 8,000 to 8,000 from A0000. Okay, but I realized that our code, when get to this jump, it was not doing here because the last instruction we are doing was this, and I said why, and then I realized it should be in loop here. Go from when get here, it should go to address 7, go there, and then decrement the address. So from this point, so it's starting this point 09. Wow. It start here 09 09 FF, and it should goes decrementing itself to 1000 because this is what it's saying that it's doing. So this LD will do something like load A, which is 0 because of this char, 0 to HL and decrement HL. So HL is 9FF, then 9FFE, 9FFD, and so on. But that was not happening because after it decrement, it was not looping. And why what was not looping? Because the bit Z was not 0, it was true. And why it was true? Because this function was wrong. We implemented this wrong. And we implemented this wrong because two reasons. One, two mistakes I did. One, it is bit 7, bit H, right? So bit H. One, the bit mask we were using yesterday, this was, let me put more better. So yesterday this was like this because I made this mistake. 1, 2, 3, 4, 5, 6, 7 bit, thinking that the bit starting with 1 and go to 8, and that's wrong. It start in 0. So this is the bit 0 and this is the bit 8. So this is the bit 0 and this is the bit 7. So bit 7 as it is it's checking if the most left bit is true or false. So that was the first mistake, and that was also highlighted by our very good commenter as his first point. He said it here. So thank you again. That I realized myself yesterday. No, not yesterday, today, this morning. But thank you for highlighting that here again. Saturno Marti. I don't know how you call, but thank you. And thank you for watching my videos. Your comments are very welcome. So this was the first mistake I did, and this is oh, actually this is the first mistake here. I think the bit 7 is this, not this. Yeah, and also it's a good idea to keep using this notation because it's easier to see the bits. I will come back again with his comments. So this second comment is already addressed, but I will get back to his comment soon. Now getting back here, after fixing this, I still not seeing the error because when I was doing here, let me do that. So the implementation of the bitcode operation, which I copied, which I implemented from from this, it says set the flag Z if bit B of register R is 0. But it not set to reset if it is 1. So then this was wrong too. If we go here, our code was something like this. Okay, so this is what we did yesterday. If bit, so I implemented exactly like it is. If bit register is 0, because I send here the complement. If it's 0, I set the flag. But I should do this as well. So if this bit is if the bit R is false, if the bit R is true, I need to reset the flag, and in this case it's true. HL is formatted by, getting back here, so HL is H and L, so it's 9F and FF. And why that is a clever way of doing this loop, throwing to this to that, because if we go here, so H, which is being tested here, is 09, it's 9F, right? Because we know that HL is those 16 bits together, but the first part is just 8, which is 9F. So 9F, you see, are seeing the first bit here, so it's 1. It goes from 9F to 80. So if I keep 80, it's still 1. But as soon as I change the first nibble, which is 4 bits, to 7, even if I set this bit becomes 0, which will be like 7FFF. So 7FFF, this jump will not occur, then we continue it. So it will continue looping here through till we have 7FF. So we go from 9FFF to 8FFF, 8000. And this is done by this. So fixing these 2 points, the doBitCode function and the bit mask, I was able to make this work. For doing that, I did this test. First, for being able to see that happening, I did this test. I did this. So yesterday we implement debug for CPU. So off screen, I implement a kind of debug for RAM. And why I did that? Because we have this, for our RAM, we have this 64 kilobytes array, okay, of each one with 8 bits, and this is how the memory is represented in my emulator. But from our studies that we did before, we know that there are parts of this RAM that are special, as video RAM, as VRAM, or object attribute management, which is this area, which is responsible for manipulate the sprites, IO RAM and H RAM. So what I did, the ROM area, I mean, we don't need to see the ROM area because it's the file. If you need to see the contents, we can open it because it's fixed. Of course, when we start implementing these memory banks, which we will in the future, we will need to see this area of memory. But for now, we don't need. So what I did, while implementing the debug, I just put VRAM, which is from this area to this area, 8000, OAM RAM, IO RAM, and HRAM. And I put this in 2 places. One, when we start the program, I just want to see the memory management unit before, as it is being initialized. And in our panicky, because the instruction is not implemented, I also put it here. As you can see, the MMU state. Okay, so, and for illustrating that we are actually putting zeros in the VRAM, I did something just for sake of me being able to visualize that. Here, of course, I already changed. If I initialize the run with like it's any value, 255, okay? So I'm initializing instead of initializing the run with 0 in my code, I initialized it with 255 because why the cartridge is initializing the memory here? Because the cartridge don't know the states of the run of the Game Boy when the cartridge is when the Game Boy is powered on, because it's a hardware, it could be any level. So this is done for being sure that all memory is clean before loading anything into the memory, into the video memory. So to be able to see this happening, I did this. Now when we run cargo run, we'll be stopping in a not implemented function. Actually, yeah. So let me show here. Yeah, it's 32. It's 30, not 232, but yeah. So here, it was an error, unrecognized LDC17, which is this row. We will get there. But then it prints out our VRAM. If you see our first print, this print, oh my god. So this print MMU before 255 is in our main. So we just initialize in the code, in our code, the MMU. As we did that, as we put VRAM, as we put every single register, every single address in the memory as 255, so the VRAM is 255 and all the other runs are 255 as well. But when the code reaches our panic instruction, it already looped through all those steps. It get here, goes from 99 and do this loop that we just implemented, because this is what the ROM saying to do. And what this do in the memory? It puts 0, because 0 is the content of register A. It loads 0 into 9FF, loads 0 into 9FFE, and so on till 8000. So it gets from the very top of the run, from here to out to here. So it's 0, 0, 0, 0, 0, 0, 0, 0, 0, and there are other part that it's good to see, because we initialized the entire ROM, so the 64 kilobytes with 255 with 255, and this code itself just just put zeros in the video run address. The OAM run is still 255, the IO run is still 255, and the H run is still 255, which proves that our boot room is doing what it should do. So we don't need to, I will not keep it as is, because I want this to be 0. So it will be 0. And I will not be, so I will not so I will also not print this before. And in our CPU, I will print the MMU state, but I will put this message at the very end so we can easily see the message, and if we need, we scroll up to see our MMU state. Okay, so oh yeah, so actually this is, so now this is MMU, and this is our byte. Sorry, okay, I need to, so MMU CPU byte, no, not CPU because it's self, byte and PC, self PC. Okay, and I will also do the same here. Oh, actually, yeah. Just copy. So here in our panic for executing, I will do the same. I want this to be the last step, just because I want to be able to see where it's stopped. So instruction and self PC. Okay, so if you run it again, okay, so we are able to see the memories. Of course, now everything is 0 because we are initializing it, it's 0, but we are able to see the run here. Including VRAM, which is huge. So okay, we know that, and now we have this Z. Now it's true. Z is true. So then we have now. Okay, so this is what I did in off screen. Okay, so let me get back to our friend's comment and see if we need to do something else. So his first comment says that in the get z flag function, it would be easier to use self. Yeah, this is return a boolean equals 0 that return a bool. Let me see. Oh, this get z flag is these functions. Yeah. Yesterday I thought that should be simpler if we do something like in one row. So self f. It's exactly what we did here. Oh yeah. If this is okay, so this will be 0 only if z flag is 0, right? Because if the z flag, which is in this position, if this flag is 1 in f, then this result will be 1. Well, actually more than 1, it will be 128. But if this flag is 0, then this result in decimal will be 0. So what it's saying that if we do self f, so this equals to 0. No, this complement of this equals to 0. that will be something different. I mean, this is something like this. Oh, and this is wrong. And actually this is wrong because it's not 7 bytes. This is way as interesting because I can do that. Okay, so you do this function get flag, and I will do self and a bit mask, which is an integer 8. Okay, and I will return, and this will return bool. Okay, so I will do this bit mask. Of course, it's equal. So and then I can just do this self get flag 0b1, right? Thank you again, Saturno. This is pretty useful and much smarter than I thought. Yeah, yeah. This should be something like this. Let's see if this is still running. Yeah, this is still running. Let me do the test. Initializing this with 255. Yeah, it was working. Okay, so it's working as it should be. Great. This is great. This is great. And much better. Much easier to read. So thank you again, Saturnus Imart. Which I, if you are watching my Twitch stream, please comment in the stream. It will be very welcome. So this is address set. This is already address set. In the LDHA of structure, the flags are not affected. I think this was something that I put need to check. Let's see. LD. Here. So here I'm checking, and he says in the LDHAL instructions the flags are not affected since LDHA decrements HL and decrement HL do not affect the flags. I think you have confused it with decrement. Yeah, I'm confusing. I think the only operations that affect the flags are the operations done in the A register. Operations do, I mean, arithmetic operations doing that. So yeah, thank you again. So this is not needed. So I don't need to set any flag here. Thank you again. Thank you again. No need to set any flag. So flags should not. Oh, I forgot to mention that For who is watching, I forgot to mention off screen I created this debug um, debug flag. It's not a very good one, but I can like do this set debug. Well, I think I could. Oh yeah, set debug flag to turn it on. Yeah, I need to put it as public, right? Yeah. I need to put as public. This is not public, so yeah. Pub function, pub function. So if I put this, if I turn this on, then we will see all the instructions being running. So this is the loop. It's doing the loop, 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 till then. Of course, it takes more time to print the screen. So now we are actually doing this loop at this moment. Oh my gosh. Maybe it didn't work. Oops. I did something. Yeah, I did something that make this not work. So if you see, yeah, HL is 00. Something went not well. I think so. Let it here. You saw that this debug flag helps, and I think what happened was something with these flags. Okay, so let me do this first. Okay, so let me put this debug here, pub. Okay. Okay, so it's already outside the bounds that we thought. So, okay, so let me do something. I will remove this because this should be removed, as our friend said. And I will review this. So, oh, I forgot the music. Oh, I forgot the music. That's the reason that things are not going well here. The music, the music. 30 minutes without music, with me just talking. No, that's not good. That's not good. So let's play something different. Let's try this. Now things are gonna flow much better. So, what's the problem? The problem is these beats that I messed up. So let me see here. 0 0. If this flag is 1, then it will be 0. This is something that Saturno said, but I'm not sure if this is the way, because this will be because self F is an integer. When I do this, it's still an integer. If I do not negative, is not operate. Rust, not integer. Rust playground. Okay, let's do some tests then. If I do if I negate 28, what will happen? and if 28 is 8B. So it's never B. This is always false. So this is not the right way, because here will be, let me see if this guy say, if it would be easier to do something like this. What I could do, because of course if this is 0, what I could do though is that if this guy is greater, oh, it's different from 0. Oh, maybe what this means is different. Yeah, it's not negate, it's different from 0, and then it works. Yeah, because for example, different from 0. Okay, so this is false. True. Yeah. So yeah. So now I think it will work. Let's see. Running. O sea, yeah. So now it's right. Now it worked. So again, Saturno Mart was right and I was wrong. I just read what he put here wrongly. Sorry. So he's right. Okay. So our debug function is also good because it allows us to see all the travel between all stuff. I think I will not put the vrun out. The vrun is so long. I will let it there. This for a while. So it's doing this loop and finish. Okay, and now we can see all the trace. Okay. Anyway, I will not do this. because we don't need this. Yeah. So okay, we did this. So we go through this, we go through this, we remove those set instructions here. For instructions BD, bitmask is missing. A, B, C, D, BD. Actually, in the decode part, I didn't put any of those. Yeah, it's missing. But I think it's not there. Yeah, I will put it there already. That's. Besides, the guy said. Okay, so let me bit. Okay, so here bit. So actually all bit code. So let me see what is bit D. Oh, I think here. Oh, I see what he said. It's not in the execution part. Thank you again. Realize that I didn't put any comma. Is that not needed? Okay, thank you. I just put there. It is still missing the decode part, but I will do that when it appears. Because it will fail and we'll go there. Well, I can't do that now, right? Let's put it there. So let me do one thing here. I will put all the codes now. So all the bits. I start with bit B. So bit B is 4 0 4 0. If this is 5. C 4 0. Okay. So instruction 4 0. Thank you, Kaizen HD. Thank you for the following. I appreciate that. Thank you and welcome to the band. So this is B, so it's bit B, and the bit that's being tested, it's the 01. Okay, so then yeah, of course it is I. And oh my gosh, what happened here? Bit. Before, okay, let me do this. So bit 41 is C. Still bit 0. Yeah. So from 1 to 7. From 0 to 7. 2, 3, 4, 5, 6, 7. So bit C, bit D, E, H, L. Is there an HL? Yeah, HL. This HL is something different, right? Yeah. Well, anyway, bit HL and 7 is bit A. Bit A. Then it start again with bit 1 B, 1C, 1D from the 8 to F, I think so. Yeah. So 8 is bit B. So for 8, 9, A, B, C, D, E, and F. And this is C, D, E, H, L, and HL. Oops. I almost messed it. So A, bit D. Something's wrong here. Bit B, C, D, E, H, L, HL, of course, A. Okay. Then we can go here. Well, I want to continue doing other stuff to load that ROM, so well, but I will not let this incomplete. Sorry, I can't. Well, this is be almost the same. Almost there. Okay. So now 50 starts with 2B. So instead of here, it so again again. That's 8 should be. Interesting. I think this is wrong here. No, it's A. No. And now it should be. Okay, so all bit. So this is done. I'll do 16. Just 2 more lines. The bit goes. Yeah, so some of those instructions will not be implemented yet. I will do that later because otherwise I will just copy and code and it will complain if that, I mean, it will panic if that's not there. So I want to go through the in CPU self-SP, and this is something that I want to take care. Self-SP and self-PC, it makes no sense. Self-SP is a stack pointer which is set to 0FFE at the beginning, which is, yeah, it's set to that at the beginning. So where is self? Oh, here. I did this because I made two errors here. One, I thought that this jump is like a call, and it is not. So I don't need to do this. And second, uh, this is not how stack pointer works. So I don't need to put it here. Need it here. In any jump, actually. So self sp. Yeah. So sp is like a at the beginning, the stack is used for push and pop instructions or jumps. Yeah, and in here it is used with call and head. Other thing that I want to take care is the timing, because I know that I'm missing here. I am not taking care of those timings, and that needs to be done. Otherwise it will not work. So every instructions, it has two modes, M and D, and both are multiple of actually 3 times 4 is 12. It's that. I think I need to set that to handle that. I think no, I am sure about that. So if I let it for the end, I will need to do a lot of refactoring. Yeah, so I think I'll do this. Let's put two other stuff here, like T, which initialize with 0, and M, which initialize with 0. Of course I need to put it here. I will put T as usize, so to be long enough, and usize. Okay, so that will keep the counters of cycles. So T will keep the counter in T mode, which is the cycle T. I really do not understand. T cycle, 2 T edges, 4 T edges. Oh, one cycle is in T mode. The cycle is 4 kHz, 4 megahertz, and M cycle is 1 megahertz. T edge, a single tick on a Gameboy clock from low to high or high to low. Okay, anyway, I will keep track of those. How do I keep track of those? Each instruction has its own time. So as the CPU has its timing, as the CPU has the time recorded here, I can do this. So in the execute, I can do this. So load SP. At the end, we increment the program counter. So we can also increment our cycles variable. So then we know how many cycles it's being executed. So if we need to do something between a timing, like I will need to wait for X cycles, then I just need to monitor those variables, those properties. I think this is something. I don't know if this is the best way, but this is one way. So I need to go back. This is good to be done now because otherwise I need to revisit every instructions. So, and this is done in the execute part, not in the fetch. I didn't like this music. I will put something more relaxing. Now it's better, much better. So, I will do this. I will increment the cycle depending on the time that is there. So LDSP LD SP LD SP. Yeah. So it's, let me put both. So it's 12T and 3M. So this will be self.t equals 12 self m or equals 3. So this is how I will take care of the cycles, of the cycling, of the timing. I don't know how that's important, but I know that's important, so I will do that. Oh, Kaizen said hello. Hello. I didn't saw that. Sorry. Hey guys. Kaizen HD. Okay. That was my first comment. Great. So, getting back to the code. So let's do this. Let's see. LDBC. LDBC. Yeah, LDBC. LDBC is also 12. 3. LDDE. LDDE is also 12.3. LDHL, LDHL, LDHL is also that. Okay, LDDHL. LDDHL, those are debug messages. I don't think that I will keep that debug message there. So weird. But okay, LDDHL, LDD. I think this is LDD, right? LD decrement HL. Yeah. 8. So it's 8 and 2. Char A. Char. Where is char A? Char A. Char C, char. AF. So AF, char AA. TM. Okay. So 41N. 41M. I don't need to keep those because it's always multiples, but let's do that just for simplification. Bit, all the bits are 8, no, not all of them. All that handles one register is 82. So this is 82. Okay, so these are A2, 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 bit. See? No. I will remove this. Sorry, but this idea is good, but the code get messy. I will remove this self-debug. I will let the ones that I read put, but this is too messy. No, I don't like that. Okay, so I'm taking care of the timing now. Okay, so JRNZ. So JR. Okay, so JRNZ. What's that? If there is a branch, sorry, we're back. Sorry, my little kitty. She was messing with some stuff outside, right? Okay, so this is a special part. If there is a branch, it's 12D. Okay, so here we are. So if this happen, it will be 12 and 3. Otherwise, I would need to put an else here. It will be 8 and 2. Okay, no problem. I think O and Z is the same. And okay, so this is NZ. This is Z. Jump Z is the same. So 12, 3, okay. Z, C, so all of them. Okay, so else. So else is 8. Who is here? Who is here again? my okay. Hey guys, we're still there. It's saying that my my Twitch connection is poor. Let me see if that's true. Okay. I'm still live. I think so. Let me see. Wow. I think I'm still live. I'm still alive. Okay, so continuing here. Let's do this, this, and this. Okay. So we just took care of timing for the odds. I will just so git. Okay, so let me see if Saturno Zmart has any other. Okay, if you change the stack, any misfortune can happen. Yeah, I hope this comment help you. Great. Yeah, it is helping. It's happening and it's helping. Thank you again. And please, if you have any other comments, go ahead and let it there. I will read this in the streaming, and thank you. Those are valuable resources. So great. So now 1 hour of streaming, we are back on our decoding. Okay, so just git add comment add timings. Okay. So continuing the development. So if we do cargo run, it is in the PC. So LDC 17. So it's this instruction. Yeah. So we already did this. We started and we need to do a LDC. Okay. So I think that's not that hard to do. So it's just load LDC LD load so LDC. Oh yeah, and it's just so it's 0E 0E. This is LDC. So it's just load. I think it's loading. Let me open this. Besides, they said this is not very trustable in terms of accuracy, but I think, yeah, LDC is not 16-bit. So it's this one, right? Yeah, LDC OE. Okay. So just put the value NN into N, yeah. So doesn't matter, but I will put it here. LDC and N. So it's just about of put self C equals N. Right? Yeah, that's it. Well, and as I did this, I can do the, okay, let me just grab the right values here. So LDC, it is 2 step, and this is 8 and 2. I can do this, so like LDA with N is the same. There are no LDA. Okay. So LDA LDE LDL so A B C D yeah, here D E F. There is no F, but there is H. LDH. So here we are, we have this implemented. So let's continue running. So it goes to 3, it goes to 3E. What's 3? 3? 3E. 3. So 3. Is this node A? Oh yeah, I think I didn't decode that. Oh yeah. So 3 E E2. Oh, he initializes something in the IO who run here. See? And also in H run. And we are in E2. E2. I think it's this increment. Or this E2. E2. Yeah. What's that? FF0 plus C. What is that kind of instruction? That is an 8-bit. So it should be here. Put okay, so this is a LD CA. Put okay, so it is something like put A into address FF00 plus the register C. So it calls LDCA. So let me do this like LDCA. Right? LDCA. Okay. So this instruction is A2. Let me do this here. So it is E2 LDCA. Okay, and how to execute LDCA? Just before, sure. LDCA. So So how it should be executed from here, put A into address FFF. I just update this because okay, so let address goes to self to FF C. And then I do this. Right byte self A. That's it. And then each is one product counter 8 2. Okay. So we should be see something here. Yeah. More stuff here, more stuff here. You're seeing some stuff here. Decimal set 120. Yeah, that's it. Here and here, here and here. Is that right? Okay. I think it is. We'll see. I think I don't need to put. I can do this stuff like just in the beginning. Then we know what is going on. Okay. Okay. Yeah, I think we are having problems with the stringing. At least it's keeping saying me that there. Yeah, it keeping dropping frames. Anyway, more drop frames. Hope there are not too much framing losing. It says that it excellent again. Okay, back to work. So let's do this. Put some debug stuff here. Wow. Okay. Okay. So we are ready for doing some crazy stuff like this, and see how we are doing. So we are doing LD, CA. We just did that. Now we are in the increment C, decoding PC. Yeah, that's it. Yeah. Okay. Okay, so we are set some parts of our memory. We need to continue decoding that. So here we have, well, we are on 15. We are on C. Instruction is C. What is C? C0, I think so. Yeah, C0. So it should be C0? No, 0C. Yeah. Increment C. So increment C should be very straightforward. It's an arithmetical. Yeah. So increment register and yeah. So let's do those inc. So we have inc C. So let's start inc A, inc C, inc B, inc C, inc D, inc E, inc H, inc L, and inc H L. Okay. Okay, I will not work with this, I will work with this. So inc A is 3 C. So 03C. Okay, let's put it there. Just before the CB. 0, 3C. B is so inc B 004. So 0C is increment C. Increment D is 014. D. Is 1C. 1C is E. There are no F. So increment inch A. It's 24. Inch L. H and inch L should be, I think, C4? Choose C, sorry. Choose C. A, B, C, D, E, H, L. Okay then. Okay, so do instruction inc A. So what we should do in case of inc A, self A equals self. Well, just do this. Yeah. Actually, no. Self A equals to self A wrapping add 1. Yeah, we need to do that. And then this is self PC 1. Which is also wrong. Now I realize that. It should also always be wrapping. I will fix it later. Well, I need to reset the flags. Okay, what I will do right now? Just me put the self t equals to 4 and 1. Okay, and now set the flags. So the flags should be dependent, set negative, set so I need to self reset and flag. If self A equals to 0, self and set if 0. I think this is right. Z set operation result. So self set 0 flag match operation reset half carry. So I think I have a doubt about this half carry. Half carry flag Z80. Still didn't get set if. Well, the streaming today is not good. Yeah. A lot of unstable events. Okay, so set the carry if bit 3. Explanation. Set if the result of the last operation, the lower half. Set if in the result of the last operation, the lower half of the byte overflowed past 15. So it says. So byte is something like this: 0, 0, 0, 0, 0, 0, 0, 0. It says if the 0, 1, 2, 3. I think what is it saying is that so it's saying that if we use this bit, so maybe, so this is 1, 2, 4, 8. Yeah. So if it was less than 15 and now it's greater than 15, it's using this bit, and then it should. Okay, so let me do this. Let a before equals to self a. Was less than. think this is the carrier flag, half carry. Because if it was less than 15, so it should be something like anything, right? Yeah, because 16 if now is this, so I carry the bit 3. Yeah, so now we have our flag set. I need to put our debug here. Ink. Okay, so now I can copy to implement every. Oh my gosh, the streaming is very unstable. Sorry guys, sorry who are watching, and I miss a game dev follower. Yeah. Thank you for the following. Yeah, so let me put some other music here. Okay, so let me copy this and put all increment B B B B B B B, yeah, C C C, oh, C C C C C D D D D D D D E E E E E E. Yeah, we are almost there. E H H H, sorry, H H H H L L L L. Okay, I think that's it. Of course, there is the HL. The HL. Well, I will edit that for the future. Let's see. Oh man, I think I need to turn it off. Whoop. So LD. So LDCH, LDHL, LDA. Let's see, LDHAL. Let's see. Unrecognized byte 77. 77. Interesting. 7 LDHL. Why that's not done yet? LDHL A. Oh, we didn't put this. So LD. There are a bunch of LDs. Interesting. So it should be here. So LD A. Oh, we already implemented CA. But this CA is not the CA for F. Let me see something for F. Okay. What's that? Oh, that's just inside. Okay, so yeah, I think we need to rename this LD. Okay, so let me do this. So this LD is LD FF00CA because it's add FF00 to C and put in the A. Foca. So let me go to LDF. Okay. And we also need to okay, so now it's correct. So now we can correctly put LD AA LDBA, LDC into A, LD D into A, load E into A, LD H into A, LD L into A, LD BC into A, LD DE into A, LD HL into A, LD XX into A, where XX is the 16. Okay, it's a U16. Okay, so now we go there and we start decoding. So let us do this. Oh, it's all here. So there are a bunch of low. So okay, LD into A, LDCA, LDL, LDAA. So let me put it here. So 0, 7, F is instruction LDAA. Okay. Sorry. Okay. LDAA, LD, where's LDBA? LDBA 047. 047, it's LDBA. LDCA, oh, LDBA. Okay, LDBA here. Okay, so LDCA for F, LDEA 5F. So this is C, this is E, LD is 6F. Okay. And we have the BA 47, the DA, DA, HL, HA. So yeah, and we also have this LD. Okay, so we have this. Let me try to execute. So let me do this. Okay, I will turn off the debug. Okay, I want to go straight to, okay. So instruction LDHL A. Okay. This is the instruction. So let's implement it. Well, I think we are still here. Yeah, we already did a lot today, and it's already late here. So guys, I will just commit here, git add, implement some opcodes. So tomorrow we will go continue from this LD. So today what we did, just to recap, we fixed some issues pointed by Saturno Marty. Thank you again. We implemented some debug stuff as well. We get these flags out there with a different way of doing that. We also fixed that pitch operation which was wrong yesterday. Now we are able to see that we are loading values into the memory. So each run already have some initialized values, IO run as well. And actually we can put it even better, because there are some special registers here for sound, special registers here for some kind of stuff. So I will separate that in the debug message, better debug message. Anyway, we already have a good, very good progress here. Of course, we still need to implement a lot. We need to implement a lot. I don't know how many, let me see how many structures we have. We implement, well, at least decoded 53 instructions, but we have 500 instructions. So yeah, probably we still need have a lot to do. We are 10% of our full instructions, and we still have video with display, and we still have sound, and so on. So yeah, guys, I think this will be a journey like for 1 month or 2, at least for me, for my skills set, and also doing sessions with like this, like 2-hour sessions per day, only in business days, in business hours. I mean, from Monday to Friday. Eventually, I will code in the weekend, but I don't know when. So, anyways, I will continue doing this daily. Please be with me, and we will enjoy. I'm enjoying this ride. This is very good. Till now, of course, it's doing this implementation may be boring, but look, we are seeing the memory changing already. So that's good. That's good. That we are doing some progress. That's pretty good. So that's it, guys. Thank you for watching. See you tomorrow. If I have time tomorrow morning, to do some stuff here, I'm thinking to start like a half-hour streaming, just to to continue working with this, and I don't know, maybe if I have time tomorrow morning I'll do that. If I do, anyways, this recordings will be in YouTube. I think I just set to the video recording stay on Twitch as well. So I think from today it will stay on Twitch, hopefully, if I did that right. So that's it, guys. See you tomorrow on my YouTube channel. I will upload that to my YouTube channel, which is in my channel description. If you go to my channel description, it is there. Just click on that YouTube logo and you go to my channel. And that's it. So see you tomorrow, and thank you for watching.